there a limit for participants tonight?
Um, Diane, you were just asking if there's a limit. There shouldn't be. We should be able to have everyone who signed up should be able to get in. So thanks for letting people in as they come. Nice, great to see people saying hi. Thanks for letting us know where you're coming from. So yeah, we're recording. So I will say a welcome. Welcome to everybody who's joining us tonight. Thanks so much for taking this sunny evening to come and learn about bees and really hone in on the Varroa mite and how we can monitor and manage that pest in our hives. We're Hives for Humanity Society, and we're a nonprofit founded in 2012, and we work out of the downtown east side of Vancouver, where we work to create meaningful opportunities for connection to nature through bees and through the gardens that surround them, through the candles, through the honey, through everything that we can build around the hive as an inclusive and supportive culture where people can gather and take real joy and take pride in their communities and in who they are and in the unique skills and gifts that they each bring. So we are very passionate about bees as a connector and excited to be connecting with you tonight through the bees. And we have our two Hives for Humanity lead beekeeper on the call with us who will be sharing their expertise. So I will facilitate and I will pass questions to Leslie Williams, who is our Hives for Humanity apiary manager. She's also the assistant director and lead beekeeper at the Sharing Farm Society in Richmond. She's also on the board of the Native Bee Society and has been beekeeping for about 9 years. I'm really lucky to have Leslie keeping our bees healthy and creating opportunities for training and education for our folks who we work alongside in the downtown east side to learn about bees and for all of us to be advocates for sustainable and ethical beekeeping for the healthiest honeybees possible. So thanks, Leslie. And Phil is here as well. Phil is our mentorship beekeeper with Hives for Humanity. He has been beekeeping for over 40 years. So lots of experience in lots of different apiaries and provinces across the country. He's been a technician, a bee inspector, has had 3 of his own beekeeping businesses and is now mentoring our beekeeping team, our staff team, our community team, coming out and sharing his knowledge and his stories of experiences in bees. So thank you, Bill. And yeah, I'll just kind of pass between these two as we go through the workshop. Thanks everyone for continuing to say hi in the chat. It's really great to see who's here and how long you've been beekeeping as we get going. So my name is Sarah and I'm the current director of Hives for Humanity. And yeah, I want to sort of take some time just at the beginning of this workshop, as we've been doing in our other online workshops, in this time where we're not gathering in the same ways, and slow down and think about how it might be if we were gathering around a hive. So this image is from one of our yards up at the Italian Cultural Center, where we do workshops and keep bees and have been raising some queens this year. And we always start in a circle, and we always start by gathering and sharing our names and making space for everyone's voice in the circle. So I do want to imagine that we're doing that tonight, and you know, as we like peer into our cameras and into our computers here, that we are in a way peering into the hive, and we are sharing space with each other. So to think about what that means and about who is able to access this space and why and how we can make spaces like this more available to people who might not have the internet, who might not have devices for accessing this workshop. And so one of the ways that we're doing that is recording it so that we can share it with our community who might not have access to internet in the downtown east side, and also to bring some of these like questions and learnings from tonight into our workshops that we are running in smaller numbers with those folks at our supportive housing apiaries and community garden apiaries in Vancouver. So yeah, I keep trying to take a breath and think about the land that we're on, and that we beekeep on and that we garden on. Um, we're on this unceded land in Vancouver of the Musqueam and Squamish and Tsleil-Waututh peoples, and we're keeping these bees that are not from North America. And we're doing this in a time of, many ongoing and concurrent crises, including a housing crisis and a drug policy crisis that are affecting people in the community we work in. We're losing more people every month than ever before to overdose. And within all of that, access to nature is still this place where we can ground and connect and grow our health as communities. So really to think about the land that you're on, wherever it might be, in Vancouver, wherever it might be elsewhere, and how you're engaging in reciprocal relationships with the land, and building inclusive opportunities for all kinds of people to come into communities of care together. So we would be gathering around the smoker, we would be lighting it up to get it ready to go into our hives, and we would, in our gardens, be adding herbs in there that cool the smoke and that calm the people. So if you've ever been at one of our gardens, you're familiar with all the sage and mint, and that's often what we're putting in our smokers. It's a really lovely way to have that calming ritual at the beginning of our process before we get on our bales and get into the hive. And always thinking about how we are stepping into communication with the bees when we enter the apiary and when we enter the hive especially, and really what our job is as beekeepers to be caring for this colony that we have introduced into a managed situation, and that we are responsible for as beekeepers, and also that we are responsible not just to our own hives, but to the hives in the neighborhoods and in the communities that we're beekeeping in, because bees are very social. Bees visit each other. And tonight, talking about the Varroa mite, the main ways that Varroa are being transferred is through bees either drifting, so visiting other hives, drones being accepted into other hives, or hives robbing, bees robbing out hives. So it's that social behavior that makes bees so strong, and it's also that social behavior that can make them susceptible to pests and pathogens like the Varroa. So yeah, I wanted to start with this really clear image here of this Varroa mite that is so devastating, Varroa destructor, very aptly named. This 8-legged arachnid parasite that clings to the bees, and we can see them with our naked eye. And if we are seeing them phoretically like that, like if we're seeing one phoretic Varroa on one of our bees in a colony, we need to know that it means there's 5 to 10 hidden somewhere in that colony. And really starting from a place of understanding that Varroa is in all of our colonies. And so we always need to be monitoring, understanding thresholds, and then treating appropriately and consistently when we reach those thresholds. So I will start turning it over, and Phil wanted to start by asking you, in your experience of beekeeping, which I believe started in 1975, what has been your relationship as a beekeeper with Varroa, and how have you seen that changing, and like, what impact is that having on your beekeeping?
I first encountered Varroa mites in 1999. I had a beekeeping business in Ontario, and I also was a part-time bee inspector. And one of the reasons I signed on to be a bee inspector that year is because I wanted to see the transition between doing bees without Varroa mites and with mites. And everyone had read about them. We knew they were coming. It was just a matter of when. And we initially did testing from mites. We filled up our smoker with high strength tobacco, which is, there seemed to be a lot of that in Ontario. And we would smoke the entrance of the hive and then plug it up. We had a sticky board underneath, and then you'd leave it about 5 minutes, take the sticky board out, and look for mites. And we started to find them in the summer of 1999. And we would find them in areas where you'd never think you'd find mites, really isolated apiaries. And people didn't believe that they had mites, and we actually had to show them what they were and give them instructions as to how to deal with them. And ever since that time, beekeeping has been different. I mean, that summer I saw hives that I discovered mites in April and May, and by September, with no treatment, they were dead. The bees had left, and the brood showed signs of what we call parasitic mite syndrome. So it was quite a shock to see this, and beekeeping was much easier before the arrival of Varroa mites.
Yeah, and Leslie, if I can just ask you the same, like, what's your experience been, and how does Varroa impact your life as a beekeeper? To unmute yourself, Leslie, I think.
Yes, thanks. It wasn't allowing me to unmute there for a minute. So when I entered beekeeping around 10 years ago, of course, mites were a complete given, and learning about bees was also learning about mites. It seemed that was just how it unfolded. I have attempted to deal with mites in lots of different ways over the course of my beekeeping career, from a treatment-free approach to using organic acids. And that will unfold as we talk through this evening. But yes, I've tried a lot of different approaches, from cultural management ones, physical ones, to chemical treatments of organic varieties.
So here is a photo of sort of like dreamy, for me, this is like dreamy beekeeping time when the bees are on the blossoms. I think that, you know, it's important that we remember, for this to happen, that we do need to be monitoring, managing. Like, this isn't just what happens. You don't get to just like let bees do their thing and they're going to be okay. And even in the no treatment method, that doesn't mean do nothing. So we will get more into that, but it's never a case in managing any crop or livestock that we get to do nothing. It is a managed system. So really wanting to tonight get into first some of the biology of the Varroa mite, and how it parasitizes the honeybee specifically, how it interacts with the life cycle of the honeybee, and what we can take from the understanding of those two life cycles. And then also, what are the different, like the array of different things that we can do to manage? What are some of the challenges with some of that management? And I think that's when we'll really get into some conversation, and also some demonstration and sharing of what we've seen work, and what we're using at Hives for Humanity. So this is hopefully a familiar one. Just a general overview, not specific in this diagram to the drones or the workers or the queen, but the process of a bee maturing from egg through larval stage into pupal stage and adult. And there is a difference between the worker, the drone, and the queen. And so this slide shows that really well. The worker emerging on the 21st day after being capped over here on the 9th. The drone emerging on the 24th day after being capped over here on the 10th. And the queen on the 16th, her much shorter, much more pumped full of queen royal jelly life cycle before she emerges as an adult. And it's really like this 3-day window is important, because the Varroa have a 10-day life cycle, so they can fit just inside of this from the capping to the emerging of the worker. The Varroa can fit their life cycle in here, but if they fit into the drone life cycle, they get an extra 3 days, which helps them to mature. And this difference is one of the differences that the Varroa have learned to exploit. So they preferentially go into the drone cells for that extra 3 days, but it's also one that as beekeepers, we can use that to manage the Varroa as well. So the Varroa then are coming in, this adult female mite who maybe has come in on the back of a worker who's been out in the field, who has been brushing with other bees and other hives, comes in like we saw on that one of those first slides on the back, an adult bee. One of the pieces of language that I love around this is that she gets called the foundress mite. She's founding in this cell her family, I guess, her generation of mites. So she comes in, she comes down the larval cell, tucks under and hides under the larva just before the capping is put on by the worker bees, so that then in those first 60 hours while she's under that capping, she lays her first egg, which is male. After another 24 hours, she lays a female egg, and then one subsequently every 24 hours. So the longer she gets to be under the capped cell, the more young she can create. That first male mates with the subsequent female eggs. They develop, they feed on that pupating bee. And then when the adult bee emerges, up to 7 adult female mites can emerge, and they will go on to found their own generations 1 to 3 more times, living like 1 to 2 months depending on the time of the year. So it really is exponential growth. They really do get inside of that bee life cycle from when it's covered by the pupal stage, covered by the cocoon, to the emerging adult. And we really do need to take advantage then of that time when they are phoretic and when they are on the backs of the bees. That's where we can be most effective in treating them. And so we are practicing at Hives for Humanity, and we recommend understanding what your integrated pest management system is. And IPM has always been what I've read about and been taught, but in a recent conversation with Xerces Society, I heard IPPM, so including pollinators in that management. So to be thinking about the impact of our IPM on the other pollinators. So not just to be thinking about the bees, but to be thinking about the other pollinators that might be impacted when we do different management methods, or when we don't do management, and when we let Varroa get out of control. And so wanting to get into some of these and start asking Leslie and Phil for their expertise and for their practices. But just as a quick overview, that cultural methods can involve things like picking locations that are well ventilated, and keeping clean apiaries, combing or culling your comb when it gets old, and requeening potentially. Physical measures or mechanical measures include things like bottom boards, which we'll get into, and drone comb removal. So taking advantage of that preference for the drone that the Varroa show. Biological, there aren't really many for the Varroa, although Paul Stamets has been doing work into fungi and a relationship there with bees. So perhaps fungi are one of the answers we could be looking to. And then chemical, and Leslie mentioned some of these, but organic acids like formic acid, and then in the case of elevated thresholds and other diseases coming in, like when we encounter European foul brood, that is when we start using synthetic chemicals. So that choice does get made at a certain point, where if we don't make that choice, we risk infesting entire apiaries and potentially entire communities of beekeepers' colonies. So yeah, we're into some of the physical controls then, and this is a screened bottom board and a sticky sheet that can be inserted. So Phil, could I ask you to share with us how you've used bottom boards and where you've seen them be effective, and how you've used sticky boards too?
Yeah, most of my experience with screen bottom boards was in the area of monitoring. One summer, I decided that the way I would try to increase the resistance to Varroa mite in my bees is just to monitor a set number every week. Bees, colonies I'd also already selected for other characteristics, and I put a sticky board in them, and then 3 days later I would take it out, count the mites, and 2 weeks later I'd do the same thing. What I was looking for, colonies that had the a low mite reproduction. So that I wanted to find colonies where the mite levels were not going up dramatically, or just be able to compare colonies. The problem is that I would harvest all these sticky boards, and then I'd set them aside, and then I'd have to count them all, and it was a lot of work. In fact, it was too much work. I had to abandon the project just because of the amount of time it took. But normally, a bottom board is used for monitoring. You put the sticky board in, leave it for 3 days, and then you take a mite count. And I'm not exactly sure what the suggested mite drop is now. It depends on the time of the year. I haven't used mite boards in a while because I didn't have colonies that had screen bottom boards. I actually had to slip the monitoring, the sticky board on my bottom board with an 8 mesh screen over the top. Leslie, did you have any experience with more experience than I did with the bottom boards?
Well, I did the same thing of using them to monitor and to count, the tedious counting of the mites. I think the main thing is that you can see that the mites are dropping off from grooming. So potentially, I think it could be an indicator of hygienic or grooming behavior in the bees, which could be something you would be looking for. But I never did it at a scientific level where I felt that it was giving me definitive information about one colony over another. Yeah.
I think that the way it's been most effective, I know research scientist Tibor Szabo in Ontario did a study one summer, and he had his children not only count the number of mites, but they looked at them under a microscope to see how many of them had been chewed. And what they were looking for was grooming behavior. And if someone's willing to do that, I think that's a good way of starting to select for bees that actually groom the bees and damage them too, so they fall to the bottom.
I mean, one of the things about the bottom board is that they can just, mites fall there, but they can just crawl back up and get back on other bees, or bees are on the bottom board also. But if it's a sticky bottom board, if you're using one of the sticky ones, or I believe, Phil, you used Crisco and something else for making it sticky, or you can buy the sticky ones, then you're actually taking those mites out of the colony. But I think some beekeepers believe, oh, they're falling down, and once they're down there, they're out of the game. But in fact, they can just go right back up if they're not on a sticky surface.
Yeah, I think it was Vaseline and Crisco, so that then the mites fall through the screen and onto the board and get stuck, so that they aren't then able to sort of scoot across the board, up the side, back in, and climb back up onto the hives. Yeah, when I was being taught beekeeping, I was told that they would fall through and couldn't get back up. But I think that understanding, as so many understandings do, has changed over the years. And I think really now we use screen bottom boards more for temperature control, and like having ventilation at high temperature times of year, and helping the bees hold heat at other times of year. Yeah. So if we also are looking at culling drone and taking advantage of that difference and that preference that the Varroa have for laying in drone brood. Phil, could you share with us a bit about how you built this frame and what we are doing here in this photo on the left?
Yeah, the frame serves two purposes. In the springtime, we insert them into colonies, and there's no foundation below that second bar. It's just open, and the bees will build drone cells in there. And then we let that hatch. We try to get it close to our mating yards. We let it hatch to supply early spring drones, because that's sometimes a problem with the matings earlier in the year. And then later on, you can use the same thing for, you can cut it out in order to try to lower the Varroa mite population, because there are more mites in the drone brood. And for that purpose, you wouldn't need a frame like this. You can just put a medium depth frame in a a full depth super, and they'll do the same thing. They'll build drone comb on the bottom, and you just slice it off and dispose of it. But you have to do it on a regular basis. A backyard beekeeper shouldn't be too difficult. You go in every 2 weeks, and as soon as it's capped, you just take it out. It's a good idea to somehow mark the top of the frame so you know which frame it is when looking down from the top. If you let them emerge, then you're just creating more of a problem with Varroa mites.
Yeah, and so we use paint on this special frame, but you often carry around thumbtacks for marking frames, which I found a useful tool. Like thumbtack means something, like whether it's a queen cell or a shallow in a deep, like a medium-sized frame that then leaves that room. And a question that I mean, I think this is something that like makes sense to me based on what I know about drones, but you know, bees will often build drone comb in those intermediate spaces, and because why? Like how do?
Well, I've read that a typical colony likes to have about 17% of its cells in the form of drone cells. And we give them all worker cells. And so they'll build drone cells in the spaces. If there's anything bigger than a bee space, they'll build drone cells. Or if a comb is damaged, they'll build it back into drone cells. So I found actually by having these frames in there where they can freely raise drones and make drone cells, they have fewer other places in the hive where they raise drones.
Nice.
Yeah. Also, I find that using one of these drone combs where they're doing their own wax, it's a very easy way to just cut out a section to do a comparative test of mite levels. So you could cut out maybe I would do 20 cells and look in every cell and see if there are any Varroa, and then I could just test in other colonies as well that have the drone comb going on. I can also recommend a method of just using a regular deep frame without foundation and just gluing in popsicle sticks along the top the way you would for a honeycomb frame, and then they will draw foundation all the way down, and you can cut it out as well. It's very straightforward. I prefer the cutout method to using the green drone comb, which I did. I have used on many occasions where you put it in the freezer after they filled it and then you give it back to them to clean out. Again, it can be an indication of hygienic or non-hygienic behavior in terms of how fast they clean it out, but I never liked giving them back the frozen brood, and they didn't seem to enjoy it much either.
And Leslie, on the right here, I included this picture of a queen cell because another method that we can do, a physical method, is to give brood breaks. So can you talk about what a brood break is and how we've used that either through splits or requeening? Yeah,
for sure. So what one might do with a frame like this that has this quite nice queen cell on the bottom is you could make a split using this frame as a one of the frames you're going to put into a nuke. And by doing this, you're taking out all that capped brood, which potentially has Varroa underneath it. You're taking it, putting it into another colony, and you're delaying the creation of more reproductive area for the mites. So you're basically slowing down the mites' reproduction through decreasing brood production at that time. Another way to do it is you can it's called a push-in cage, where you put a queen underneath a cage which restricts her to the frame, so she can only lay in this one area. And again, there's less brood being produced, so there's fewer areas for the mites to reproduce. These methods are good for slowing the exponential reproduction of the mites, but it's not going to bring the mite levels way down. It's just going to slow the climb. And another way you can do this is if you are going to just introduce a queen cell into a nuke that you've made into a split, you can just delay introducing that queen cell, maybe give it 10 days, check, make sure you don't have any other queen cells that have been built by the bees in the meantime, and either introduce a queen cell then or a mated queen.
Mm-hmm. And just a question from Diane on the green frames. So if folks are buying those green frames, which have the foundation that is a larger size cell, that is the drone size cell, bees draw it out, queen lays all drones, they cap it, you remove it, you freeze it. Yeah, I've seen two methods. One where you like give back the frozen drone and the bees clean it out by pulling out the drones, and the other where you scrape it all off. Have you done both of those, or do either of you have experience, like if you are using those green frames?
Yeah, I've done both of those. I find that they don't like the frames very much after they've been scraped off. They don't tend to want to work in them very much, or they'll work on them partially. I don't know, Phil, have you experienced that one?
No, I haven't used the green combs.
I had that happen too. I remember thinking that it would be easier for them to scrape it. But also with scraping even regular foundation, like unless you really like dip and boil and clean and re-wax the foundation, I find that they ignore it. Like maybe they can't clean it enough, or like I'm not sure, but I've had that experience too. Krista was just sharing that she gives the green frames to her chickens after she freezes them and lets them clean up. And yeah, we do that with when we cut off too. I'm always looking for neighbors with chickens who are down for, you know, a Ziploc full of brood. It's a great use. We also have like shared them with chefs who are interested, although if you do have a Varroa infestation, that's not such a delicious option. But yeah, that larva is nutritious and edible. Just another question on the length of a brood break, Leslie. A 2-week brood break, is that what you would try and aim for using whichever method?
Yeah, I mean, the cost of the brood break, of course, is the buildup of your colony and potentially your honey crop. So I mean, if you do a walk-away split where they're going to make their own queen, that's going to be 6 or 7 weeks until you have brood in there again, regularly producing. So you can do it that way, and that really reduces the mite population. But balancing your future honey crop and the population of the bees with the management technique, I think, yeah, 10 to 14 days, I think is a good solid decrease in the exponential buildup.
So if we move kind of up our IPPM pyramid, we're moving here into some of the chemical treatments and starting, oh no, this would still be more monitoring. I'm not moving into the chemical treatments yet, but we're using either alcohol or sugar to do a wash. So this would still be physical practices and monitoring. And there are some videos, and I will link to them along with a bunch of links at the end of this presentation. One really great video by Randy Oliver, whose photos these are. Scientific Beekeeping is his website, and it's like very dense with like really accessible practices and research. So this is some photos of him doing an alcohol wash with his bees to count Varroa in his colonies. The alcohol does kill the bees, so there is an alternative practice which is using sugar powder, a similar setup and a similar way of counting. So I might leave the videos, depending on our time, we could play them, but I will share them both. There's a video from the Ontario Beekeepers Association for the sugar wash, and it's about 6 minutes, so really going through all the steps. Yeah,
Can I ask a quick question?
Yeah, please.
So the mites, they don't have a complete metamorphosis, right? So they come out and they look basically the same. Is there ever a size difference in the mites when they first emerge, or are you always expecting to see that sort of like, I don't know, pinhead?
They look different when they're in the cell, like, but they come out fully matured.
But if you do a mite a mite test,
Yeah.
they're always going to look the
You're going
same.
to get the adults, yeah. When they're in the cell maturing, they go from small and white through sort of like pink to that hard looking red. But when they're out,
And
and the
there
ones
is like
would
a
be
size difference
collecting.
throughout the.
I don't think so. Maybe, but
So they don't really have larvae, right? They just come out of as mites and then just
eggs
get.
and then yeah.
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 Thanks.
Yeah, Phil or Leslie, do either of you want to add to that?
No, that sounds correct.
Although I do think it's, I didn't realize how long they could live. They can live up to 8 months,
Yeah.
actually in the fall. And like honeybees, they have a shorter life cycle in the summer, only 2 to 3 months.
Yeah.
5 to 8 months in the fall.
Yeah, so they will stay in there all the way through the winter, and they aren't growing in that exponential growth, like, and the honeybees aren't either, but they are in there. So we need to know the levels so we know what to look out for in the spring. So yeah, this is these two photos. This is this alcohol wash. So Phil, could I ask you to describe like how you do and why and when you do the alcohol wash, and also the difference with the sugar roll method, and then we'll play the videos if we have time, but otherwise I will share the links both in this presentation and in the follow-up email, and would encourage everyone to watch them a couple of times. They're really great.
I used the alcohol wash when I was an inspector in Ontario because that was the method we used, and we would use a cup of bees. So we would shake bees off the brood frames, finding the queen first and putting her aside, shaking bees off, nurse bees off the brood frames, and then taking a cup of bees, which is approximately 300 bees, putting it in a jar, and then covering it with alcohol. In Ontario, we actually used to use windshield washer fluid. And then we would shake it. And then at that time was a slightly different procedure. You would pour it into another container. What you wanted to do was get rid of the alcohol and the mites. You want to separate them from the bees. And the alcohol actually makes the mites fall off. And then you would count the number of mites and you would divide it by 3 to get a percentage. So if you had 15 mites from 300 bees divided by 3, so your percentage would be, you have what was called a 5% infestation level. And then I went to, for my own bees, I used to do sugar shakes because that's a method you can do and you don't kill the bees doing it. And again, I suggest people could look at the video for that, but I've done both and found that they're comparable. You can get just about the same readings, either using the sugar or the alcohol as far as a percent infestation level.
Yeah, and I'll share just a glimpse of the return of the bees after the sugar video, because it is a bit of a longer video, but she rolls them and shakes them and returns them, and so yeah, this great benefit, which is that they are not killed. So yeah, this is the Ontario beekeepers video, and this is after.
And they can be a treat for those at home.
Yeah, little ghost bees there. So I'll just go back to our PowerPoint. So yeah, I'll share that link because it's a great video and it shows all of the steps. So question from Alan asking, do the mites become infertile after a certain period such that a hive is requeening, which takes 3 weeks set back the mite reproductive process? So I think that if I understand the question, and if I also understand the mite cycle, is no, they're fertile until they die. So they are fertile for the whole period that they're alive. So if it's in the summer, those mites are fertile for 1 to 3 months, doing that like pretty exhausting cycle of founding their own generations 1 to 3 times. And then if they're winter mites or fall mites, they will live longer, but they're still fertile when the bees start laying, and then there's larvae for them to infest and feed on and start growing their own populations again. Leslie and Phil, I don't know if you see that question or understood when I read it, but the break isn't such, we're not, the brood break isn't because the mites become infertile. It's just that it slows down their ability to reproduce because there's no larva for them to sneak under and then breed under while the larva pupates.
Yeah, correct. And if they're not in a cell, then they're more likely to be groomed off the bees.
Yeah, so at winter time when they're phoretically on the back,
Mm-hmm.
they're more likely to be groomed off and then fall down.
And of course, I think, Phil, you said this, but the monitoring only detects phoretic mites. It doesn't detect the mites that are inside the cap brood, which Sarah, you were referring to early on in terms of when you see one phoretic mite, that indexes that there are 5 to 10 others underneath the cells.
And generally a 3%, I think Phil, you were saying a 3% during the mid-season. If we're doing these tests and we find 3% mites, that is a level that is our threshold and that we would treat at. And later in the year, it's a 5%. Like if in the fall we're seeing 5%, we definitely need to be worried and treat.
Yeah.
I would stick with 2 to 3% in the fall and not go as high as 5, and 1 to 2% in the spring.
You're kind of in trouble, right? If you're at 5. So yeah, I'll come into this next one because so far we've talked about some methods for reducing and interrupting the mite cycle and for monitoring either through drone brood, looking through and seeing how many mites. Leslie, you were suggesting 20 cells and comparing hive to hive, either doing the alcohol wash or the sugar roll. But then we use formic acid and we do that as a standard in our hives. So Leslie, could I ask you to talk a bit about formic and how we use it and when and why?
Yeah, so we use it in the spring and the fall, and so to translate those temperatures, which the temperatures are so important, so it's 10 to 29 and centigrade for when you can apply it, which makes it a bit tricky in the spring. We wish to get the treatment on as early as possible, but getting a steady 10 degrees where it's going to be 10 degrees over the course of a day and not drop too much the next day so that it's not effective. So that we're waiting on the temperature for that. Basically, formic affects the mite's tissue and respiration, so that causes them to die through attacking those parts of their bodies. And we have gone to a 1-pad treatment, 2 1-pad treatments rather than a single double pad treatment, because we've found we suffer queen loss more often if we do 2 pads at once. So we are putting one on as early as we can in the spring when the weather permits, and then trying to do the next one around 10 days later. Again, it's the weather is a bit tricky. In August, when we put on our second treatment, heat can be more of an issue because, again, queen loss can be exacerbated if you're at the outer edge of this heat range. So trying to find a 10-day period where the temperatures are more around 20 instead of in the upper 20s is good, because again,
do you remember the timing of this season? Patrick was just asking when we, and this is the Formic Pro, this is the instruction from the Formic Pro package, which is the product we use, and instructions do change and have changed on these packages and these products over time, so always to follow the instruction on the package. But yeah, do you remember the week, the month from this season?
I think we would often start it in April if we had the warm enough temperatures.
Mm-hmm. Yeah, Phil, do you have anything to add, like your experience with Formic and any recommendations for application? One of the things I have done wrong in my beekeeping career is put the pads on the wrong direction. So I put them in line with the top bars instead of across the top bars, which was a mistake and not the right application. So yeah, any sort of like tips or any questions from anybody on the call?
There's 2 options here. One, you can use 2 pads at a time, and when you can use one. And I'm an advocate of the one strip at a time. You're less likely to lose a queen, and you just have to do it twice. But it's quite effective, one strip at a time. And just make sure you follow the instructions as far as uh, that are in the package, as far as giving the colony ventilation. You don't want them restricted for ventilation at that time.
And
Diane, go ahead, Leslie.
one other note of caution on the, is to pay attention to the expiry date on the formic, because I thought, oh, if it's a little bit expired, it just means it's weakened. But in fact, the issue is more that the medium to hold the formic degrades. And so potentially the formic could be released too rapidly. And again, having an issue with queen survival in that way. So it's not the way we think of our own medicines and of, oh, my allergy medicine is a year old, but it's just a little bit less effective. It's actually, it can be more problematic than that with the formic.
Mm-hmm. Diane, did you have a question as well?
Yeah, I just, from personal experience, I did try the 2 once with the new stuff. You know, I know that with the old stuff, it was a bit iffy, but I thought this stuff was so controlled. You know, you don't smell it quite as much when you take it out of the package, etc. But I had a lot of bee death from it. So I definitely won't be doing that again. So that was something I learned this year. But I guess I wanted to ask more about how stringent you are about the don't like inspect a week before and then let them go for a week before you put the acid pads on. And if you can tell us any more, like, has it worked for you if you just do 24 hours or
We're not stringent about that at all.
so
But we
do
do
you
24
inspect
hours we use,
and
I
put
think.
the pad on immediately?
We sometimes, against the advice of the package, we will sometimes inspect and then just put the pad on, because we're there and we are traveling around to lots of different apiaries.
Sure.
So, and we have had
You haven't
problems.
noticed anything really detrimental?
No, it might be that maybe if especially a new beekeeper is taking a long time to inspect and they're going through and the bees are really disrupted at the end of it, that might be more of an issue. But if you're just going in, making sure the queen's laying, making sure there's, you know, things are generally in order, and then treating.
Mm-hmm. Okay, thanks.
Yeah.
And Anson had that question about having honey supers on. This is really the only treatment you can use with honey supers on. Formic acid is a natural component of honey, and it dissipates fairly quickly. So that is one advantage, is that you can use it when you have supers. If you have metal excluders, it tends to rust the excluder. But other than that, there's no problem with honey supers.
Also, I've used, in terms of honey supers, when I've been at the upper range of the temperature in late summer, and for personal reasons, I had to do the treatment because I was going out of town and I didn't want to wait any longer. I put an extra empty super above the brood nest, so there was a little more airflow. It kind of reduced the congestion within the colony under that heat, so that they could have a little more movement if they needed to. I read that as a suggestion somewhere. So that seemed to work well under the high 20s temperature.
So I want to keep rolling and get in a bit to like what is happening to the bees when the Varroa are parasitizing them, and this is some drone brood that I pulled out when I was doing an inspection, as Leslie suggested, like going through the drone brood that I'd called and looking, and you really can see them. They are very visible on the backs, these red Varroa on the backs of the developing drone pupa. So yeah, Leslie, can you share a bit with us about what they are feeding on, what the Varroa are feeding on, how that understanding has changed in recent years, and what else might they be vectors for?
Sure. Yeah, it's quite interesting that for decades, scientists thought that the mites were eating the blood or the hemolymph of the bees. and an entomologist a few years back looked at the mites and thought the mouth parts aren't right for a blood-eating creature, and the digestive tract was also not right for a blood feeder. So that began a whole series of questions, which led these entomologists to discover that the mites are consuming the fat body tissue of the bees. They, when they tested, they saw that all of the mites that were actually feeding were wedged underneath the abdominal plates of the bee, which was where fat body was. They also did an experiment where they fed mites hemolymph, and then they fed another group of mites fat body. And the ones that were fed hemolymph died, starved to death quickly, and the ones that were fed fat body did very well. So that there's a lot of research now coming about as a result of this recent discovery. So there should be some interesting information and hopefully coming along soon about what effects this has on the bees. We do know that the fat body tissue, which is like the liver in mammals, is responsible for immune function and pesticide detoxification and overwintering. So really important aspects of the bees' lives.
And perhaps one of the implications might be into how we treat is, you know, perhaps a different treatment might come from that different understanding.
Yes, there's been an attempt to feed bees certain things that would then kill the mites through feed them a toxin that would come out through their fat body tissue, but it didn't work. So I think there's an effort to attack the mites through the fat body tissue, but that's pretty a tricky endeavor. So we'll see how that works out. So the Varroa are directly affecting the body of the bee, and then they're also directly affecting the bees through vectoring viruses. There are 5 major viruses that are vectored through Varroa, and then there are 13 others that are suspected. And we're running out of time, but just you've heard probably of deformed wing viruses, the most famous one and most easily spotted, but there's also acute bee paralysis, Kashmir bee virus, Israeli acute paralysis, and chronic bee paralysis. So, yeah.
I put this photo on just of the deformed wing because it is the one that I think is another one that you can really see. And if you were seeing this, you have high levels and like you need to go into like emergency treatment of your bees, right? Like this is like you've passed the point if you're seeing this.
Yes.
And then to put this one on and to kind of and to keep going, like this is again like this is trouble if you're seeing your brood like this. So Phil, you mentioned parasitic mite syndrome at the beginning, and we're round to it now. So can you take us through this a little bit? What are we looking at?
Well, parasitic mite syndrome, often the cappings are slightly broken. The bees are trying to figure out why the pupa died inside. This one I see it looks like a chalk brood over to the left. Yeah, that one there. But basically it can be mistaken for foul brood parasitic mite syndrome, but it's the viruses have just gone rampant. And by this point, often a lot of the bees have abandoned the hive, so you also get chilled brood. And I saw it once in a hive, and I thought it was foul brood, and I burnt the hive. But as I was throwing frames into the fire, I looked and realized it wasn't. It was parasitic mite syndrome. The mites had just get out of control, and that's the irony of Varroa mites. The more brood that's produced in the colony, the more mites you'll have. So sometimes your most productive queens, the ones that produce the most honey, are the ones that are going to crash in the fall or winter if you don't deal with the mites.
Yeah, I've experienced that for sure, like being really stoked on a colony and getting like 3 supers of honey off of it, and then it being the one that crashes. And yeah, I moved to this this slide, which is from Randy Oliver's Scientific Beekeeping. So Phil, can you also like walk us through this slide a little bit?
Yeah, this shows the population growths of both the bees and the mites. And the mites start off really slow in the springtime, but there's an exponential growth. And by the time August comes around, if I have high mite population, and then your bee population is starting to go down. So the effect is compounded by that. And so what this shows actually is that you want to start treating your bees in this area, sort of mid-August. The honey flow is over then anyways by that time. And you want to protect those bees that are being produced then, because they're the ones that are going to go through the winter. So it's best to get your treatments on by mid-August. If you wait till the end of September, it's usually too late.
Yeah. And so we treat once in the spring, all of our hives with Formic, 1 pad, 2 times, 10 days in between, and once as soon as we can, temperature-wise, in August, 1 pad, 2 times with 10 in between. And typically we don't treat in between. Diane was just asking if we treat between spring and fall. But we would if we had like a really high infestation rate.
Sure.
Yeah, for
How
sure.
often do you check? Oh, I'm muted.
No, we heard you. How often are we checking? Like, how often are we monitoring? Are we doing mite rolls? Is that the question?
Yes, exactly.
Yeah, we're doing occasional sugar shake checks, and mostly we're doing them in early summer, sort of between the treatments, to see if we're doing okay.
Yeah, so checking that drone brood as we go through the season, making sure we don't have really worrying levels, and then doing sugar rolls throughout the season to make sure we're on track. So we are, Anson is asking, does that mean you treat without testing? So with Formic, we are treating in the spring and in the fall with this organic acid across the board. It doesn't harm the bees when we do it at the right temperature and the 1 pad, so that then we know we have Varroa. Like we know we have Varroa in all of our hives and all beekeepers, and it's safe to say.
Yeah, we're seeing Varroa, so
yeah.
All the time. Oh, and by the way, Patrick asked, I think the date we treated on April 10th was our first treatment.
So yeah, I wanted to show this because it's kind of nasty, and it can show, this was from one of the provincial apiculturalists photos. This is like when it can get really bad. So this can happen. I'll move past it, but it can get that bad. So this is really what we're trying to prevent. Like we don't want to see this. This is like terrifying and really sad to see in our bees, and will result in the entire colony collapsing. So we really want to be more like more on top, like always monitoring, and having our treatment plan, and knowing if we've gotten out of control. So I did want to just share this photo after that rough one, but also to say like that, you know, when we're beekeeping in the city, we're beekeeping around like our own colonies, but there are so many colonies, beekeepers beekeeping in rooftops and backyards. This is us on the Vancouver Convention Center. And we won't get into it too deeply tonight. I am going to share a bunch of resources that I will email out. But there is, you know, there are feral bees that do live and survive. They have very different, life cycles as a colony than do our managed hives. And there are some beekeepers in some situations that do practice a no treatment approach. And Phil, can I ask you to just like speak to your sort of like expertise and opinion about when this is practical and where this is possible to do this like no treatment style?
If you were isolated and there were no other beekeepers close to you, and you wanted to sacrifice a lot of your colonies, you could just not treat, and then the ones that survive start raising queens from them. And if you did have isolation, then you would also be in control of the drones, because if you're close to anyone else who's not doing a selection progress, your virgins will mate with those drones and you won't make any progress at all. Also, what happens in these feral colonies that are in trees, they'll swarm, and actually swarming is a good way to reduce the mite population because that gives you a brood break. We always try to control swarming, and by doing that, we're allowing the mite populations to increase. So the reasons we really use chemicals now is that it's sort of a stopgap measure. I almost compare it to what we're doing with COVID-19. Like we're minimizing the spread of that virus by, quarantining and physical distancing and travel restrictions. And it's similar to what we're doing with by using, let's say, formic acid. If you were just to not do anything, you'd probably lose 95% of your colonies. And so we're trying to still maintain the bees. And commercial beekeepers are still trying to stay in business. And the only way to do that right now on a large scale is to use some sort of treatment to keep the bees alive.
And Leslie, you mentioned at the beginning that you'd had some experience in this. Do you want to add to that at all?
No, I like the way Phil put that. I mean, ideally, I would definitely prefer not to treat, but I tried very hard, lots of different management techniques. And I had okay survival, but I also was really battling deformed wing virus. It was regularly appearing when I was not doing any organic acid treatment. And it finally came down to the amount of work to do these management techniques, and then trying to also get a honey crop in if I was doing a lot of brood breaks. And one year I thought, okay, I'm going to try formic acid, and the health of my bees went up really dramatically. So I sort of started taking it into account as a way that I could keep them healthy, and try to do as many management techniques as I can to reduce the mite load as well, so that it's not just through the formic that I'm reducing mite loads.
Yeah, and just moving to this next slide, and this Osmia, this orchard mason bee on the left here, and I don't know if you can see her, but she's pretty heavily loaded down bumblebee there with pollen. Just to ask it, and I'll share the resources as well, but honeybees affect wild bees. We know that we need to be planting for the wild bees. There's enough forage for them, and protecting undisturbed areas of habitats. There's places for them to nest. We know that like messy gardens are healthy gardens, and that we need bloom all year. How does our management around Varroa mite impact the wild bees?
Yeah, this realizing about the effects of our managed bees on wild bees was also part of why I began treating with formic, because viruses are found in all different kinds of non-apis, as in Apis mellifera, pollinators, all different kinds of wild bees. And the mites don't feed on other bees besides the honeybees, to my knowledge, but the viruses that the mites vector and spread throughout your colony can then jump to other species, from bumblebees to mining bees to mason bees to all the different kinds of bees. There's a good bit of research on the viruses shed through feces, and then it's on the honeybee as it goes onto the flower, and it contaminates the surface of the flower. So the shared flowers are actually become a site of viral transmission. So native pollinators are also under so much threat right now, much more so than honeybees. And anything that we can do in our management practice to prevent more pressure on native pollinators, I feel is really the ethical thing for us to do as beekeepers.
Yeah, thank you. Yeah, totally. I think in our beekeeping practice, like at Hives for Humanity, and with all of our beekeepers, and I'm learning from you and from Phil, and from my mom, who was a beekeeper with us since founding until last year, it really is like, what can we do to have healthy bees, and what can we do to understand the impact of our honeybees in our communities? So whether that's education, and connection in our human communities around inclusion, around the culture of the honeybee hive, and then also like into the impact on wild bees and our ecosystems, even beyond wild bees into other pollinators. Like really, like as beekeepers, like we're not isolated, and we are having impact. So acknowledging that, and then doing work to use these honeybees as an opportunity for connection and for health for all. And so, yeah, I have these 3 slides here, which I will send out tomorrow. I will send these all out to everybody who registered through the Eventbrite. So the Randy Oliver Scientific Beekeepers, some of the photos, and there's this great video. The Ontario Beekeepers Association has actually a number of videos, but that's just one of them. Also, there's the Provincial Apiculturalist. We have a really great program in British Columbia, where if you are concerned about your hive, if you think you have an infestation that's out of control, you can call a bee inspector and they will come and help you. And there's lots of resources on there as well. We got into some of these conversations. So these are some of the papers that we're drawing from around the fat body tissue, the spread of diseases to wild bees, parasites in bumblebees, and like 4 really great websites for treatment-free research if you are curious and understanding more about that. Also some research that we found, that Phil found and shared. So Phil, I don't know if you want to speak to this, but just like thinking of other voices and research that maybe hasn't been given light before. This is a Black man in America, and I can't remember when he was alive, but did a ton of research like much earlier around understanding how bees see and color and understand time. So I've started reading this week. Phil, do you want to add anything to that, like from what you found in reading Charles Henry Turner's work?
Well, I just came across his name just this past week, and I found it fascinating because I really haven't seen it anywhere in the, in the beekeeping literature. He was born just after the Civil War. He was one of the first Black people to get a PhD in the U.S. He couldn't get a university job, so he wound up teaching high school. But he did a lot of research on bees and other invertebrates, and just wrote tons of peer research papers, but he doesn't seem to have been recognized very much. In fact, he did some of the work, sort of preliminary work, that Carl von Frisch did, and von Frisch never even mentioned Turner's name in his research. So it's almost like he was just ignored to a certain extent. So I think it's interesting to get the information out in the research that he did over 100 years ago.
For sure, and especially in this time when there is such a call to slow down and listen to the voices of Black and Indigenous people of color, and to center those voices. You know, I think we can do that in beekeeping as well as in our other spheres. So there's definitely places in beekeeping where the language of beekeeping and where who gets to beekeep. Yeah, there's racism in beekeeping too, and so learning to think about that and acknowledge that, and then start to share some of those voices and change that. And there's some really great organizations. There's actually one in Detroit, Bees in the D, who we've looked to before, and who we got to meet at Apimondia a bit. So like other organizations doing similar work, building inclusion through the culture of the hive. So yeah, I will send all of those out. I'll also send these out, so those resources around planting and around learning more about the diversity of bees. Our website and social media, we will do some more of these workshops as we progress through the season. And also Diane's contact if anybody is in the Dunbar area and heard about this through that community association. But yeah, wanting to really say a thank you. Thank you for sticking around. We went over as usual. We could probably continue talking about mites all night. But yeah, thank you to the team at Hives Through Humanity, Leslie and Phil, for sharing your experience and your thoughts, and really specific examples of how you're managing mites. And Diane for being here and asking questions as ever, and for the work you're doing up at Dunbar, and for the work you did to get these some support for this series too through the neighborhood small grants on the west side and the Kitsilano neighborhood house. So yeah, I am going to find the unmute button so you can unmute yourself if you would like to, and ask questions. Okay, so I have allowed everyone to unmute themselves. So if you would like to ask a question on the mic, you're welcome to unmute yourself and ask. If you have to go, absolutely, no problem. Thank you for being here, and we'll look forward to seeing you around in community, seeing some names on here. And I miss seeing you in our gardens, volunteers and beekeepers out there. But thanks for joining. Thanks for joining tonight. And yeah, thanks again, Leslie and Phil and Diane.
Thank you very much. It's Vivian.
Oh, thanks, Vivian.
It was great.
Good.
Very helpful.
Good.
Bye, Sarah. Thank you.
Sherry, good to see you.
Hey, Sarah.
Bye.
And thanks, Patrick. Glad you're finding it informative. Thanks, Alan. Thanks, everyone, for your questions throughout, too. It really helps us keep animated.
Thank you.
Yeah, for sure. Oh, thanks for saying thank you. Nice to see
But
you.
I'm going to disappear now because it's 3:15 a.m.
Oh, wow. Where are you?
UK. I'm in England.
Oh, that's so cool. Thanks for letting us know you're in England. Oh, how did you hear about it?
Eventbrite.
Oh, right on. Wow, that's so cool. Well, yeah, check us out on the website and maybe we can see you for some more of these. That's really neat.
So obviously some of the local information is not much use to me, but some of the
Right.
other stuff will be.
Good, good. Oh, thanks everyone. Okay, well, I will end the call then and say goodnight, and we'll post this on our website, and yeah, look for more through our newsletter or our website or through the Dunbar newsletter too. Okay, good night.
Night.
Right.